Hello. I'm here to talk about API caching and Bruce Willis. Why Bruce Willis? Because the two talks I've seen on API, on caching of whatsoever, used his name as an example. So I just committed to memory, and now wherever I think caching, I think about him. So that's what I'm going to use. All right, so you got some static content that's pretty straightforward. You've got an HTML page or whatever. How do you make it cacheable? You set some headers. This is just pseudocode. So you can set a header cache control, private, max age, let's say 365 days, and you say that it expires a year from now, something like that. So this is quite awesome. Whenever you do something like this, just think about caching something public. This means that a CDN in front of your site can cache that data as well. And once it has the data, it won't even go back to your server. Now that's out there for 365 days or less. And now you've effectively grown your site, and you can handle billions of users if they want to come to you. All right, now once you have some dynamic content, it's going to get harder. Who uses Grape to write APIs in this room? 400 hands have been raised for those that are watching this live. So Grape is a DSL to do RESTful APIs. It sits next to Rails. If you're building a Rails application, it's rack-based. I love Grape. I think it's an awesome project. It's really simple. So here's a counter. We're going to return a count, and we can set some similar headers. Unfortunately, this is completely dynamic. So what we want to do is do the exact opposite. We want to tell that caches in front of us, CDNs or the browser for that matter, should never cache the data, and tell them, please go back and ask me, the server, again to get this data. So how do you do that? You say it's private, so it's a per user cache. You say it will expire right now, and you have to revalidate the request. So if the server is down, it will still go and fail instead of returning a result from a previous cached session. And then, of course, for some reason, you have to say that it expires in 1990. That date is extremely special. Nirvana was heading the VH1 charts on that date. I think that's why. All right, so with this, the client now has a piece of data, and you'd want to basically say, oh, I already have it. Just give it back to me if it hasn't been changed since last time. So one thing you can do on the server is set a header that says LastModified, and you say the date. LastModified counter, right now, awesome. It's Saturday 23rd, and so on and so forth. And then the client can come back and say, just give me this data if it hasn't been modified since that time. Now, this works. In fact, if it hasn't been modified, you can emit a 3 or 4 not modified, and we have content length 0, which is what we want. This has one obvious issue, is that those timestamps have a granularity of seconds, so it's not going to work for a counter. You'll miss some of the counts, which is really, really bad. So the solution to that is to set an ETag. An ETag can be a hash of the data, and so you set this ETag. The client comes with if none match, and you can return a 3 or 4 not modified, same 0 content length. That's great. There's 2 rack middlewares that do that for you out of the box. Rack ETag will set the ETag, and rack cache knows how to respect that. And it will, now you're sending the content only once. If the content were to be the same, then these will return a 3 or 4 not modified. Great. Unfortunately, while you think you're winning, you're only winning on the bandwidth. You still need to do something on the server side. And for an API, kind of the meat of the operation is server-side. And now you're going to do all this calculation, and then you'll send nothing. That's really wasteful. So what can we do about that? We can use cache, and cache in this case can be Rails cache or something like that, any kind of cache implementation. So you can do cache do, and give it a name, count, and return the count, and then invalidate that cache whenever the count changes. Now, that's a little bit tedious with all this cache key, so let's try to come up with a generic cache key to use everywhere in our API. So here's a generic cache key. We're going to inject the version of the API. the path of the request. This is your typical RESTful API, which uses the path of the resource as part of the key. And maybe the request parameter. So if I did order by blah, I'll get a different result. Now, this is awesome. We'll just MD5 the thing, and we've got ourselves a perfectly ready ETag to go out of this. Unfortunately, none of us have the luxury to use something like that because we work on real-world applications. And real-world applications are way more complicated. So there's a ton of dragons that need to be shot in this. The first one is that, oh yeah, this is a cool picture. The first one is that in a real-world application, relationships between objects can be more complex and cannot always be expressed by a route. You don't always put user stuff behind user ID, stuff, widget, or something like that, and so on and so forth. So what we'd really want is some kind of binding to by parameter. So what we want is a cache where we can say that this cache depends on these other things. And then within the cache block, when I have a miss, we can execute the code. We also have, and somebody talked about this, I thought it was very good today, we have role-based access. And role-based access can be really complicated. A simple example is I'm an admin or I'm a user, and I just want to partition my cache by role so that users who are regular users get one piece of data, users who are admins get a completely different piece of data. So we'd like to bind by this partition, and most importantly, you want access denied in there. So whenever the first time I go and request a resource for the regular users, I want to emit an access denied. I don't want to return the data from the previous cache. Those are some awesome bugs. If you hit those, log in as a user, hit the site, log in as another user, oh, you get some previous data. Awesome. With all that in mind, you also have to think about invalidating the cache. And invalidation might be something like invalidate by class, so say a widget, and maybe an instance. So in this case, I had an object that was bound to widgets, and this is a widget. So whenever I change a widget, I'd like to invalidate all widgets because maybe a collection of widgets included me, something very simple. And then I also want to invalidate any request for this particular widget. All right, that's great. Wouldn't it be nice if we were able to combine this somehow with a if-none match? Now, we served some data to the client. And we have the client coming back to us and saying, here's an ETag. And I've got an ETag. Please tell me that the data has not been modified since the last time I've had it. But we actually don't want to hit the database or whatever the inside block is. We just want to look at that ETag and being able to say, if the data hasn't changed, just give it back to me. Now, if we have the binding, then the binding can tell us enough information. So all we need to do is maintain a very simple index between those ETags and the bindings themselves, or something derived from the binding. And we can tell the client that the data hasn't been modified without even going back to and doing any kind of processing. All right, so this is what we're open sourcing today. And you can use this out of the box with Grape and Mongoid. This is kind of our frameworks we use. And this can be extended to other frameworks quite easily. This is the syntax that I've described. It basically gives you server-side caching bound to a variety of possibilities. So it's called Garner. It's GitHub Art.sy, the company I work for, which is awesome, Garner. And to garner means to collect things from all over the place and put them in one single location so that they're in front of you, accessible, readily accessible. That's kind of like a cache. It also starts with a G, which is the same as Grape, and those work really well together today. So I thought that was appropriate. So I encourage you to try the gem. If you have an API caching problem, we've been using this code in production for quite a while, and it saved us tremendous amounts of processing on the server. And it really combines this key concept that the client, once it has received the data, can ask the server whether it has been changed. And you can do all kinds of bindings beyond the very simple route-based bindings to actual domain models. And said, thank you.